Okay, so in this video we're going to be having a look at some GCSE grade 7, 8 and 9 maths exam questions that were all taken from Edexcel June 2018, paper 1. So the first question says, prove that the square of an odd number is always one more than a multiple of 4. So the first thing we need to do is highlight some important information that we're given. And we're being asked to prove, so we're going to be using algebra. It says that the square of an odd number is always one more than a multiple of 4. So those are the three things that we need to take into consideration here. And I'm just going to work through the sentence and create algebraic expressions for each of these three things. So it says square of an odd number. Now we know that n is just any number, just like x. We always put any number into it. So if we multiply that by 2, that's got to be an even number. And then if we added 1 to that, so we got 2n plus 1, any even number plus 1 has got to be an odd number. So I'm going to take 2n plus 1 as my odd number. You could have also took 2n plus 5, 2n plus 15, 2n plus 99, whatever, as long as you've got an even number plus an odd, so 2n plus an odd number, that will give you an odd number. And now it says is always one more than a multiple of 4. So this is what I'm trying to aim to get. So the first thing I'm going to do is I'm going to square this 2n plus 1, as it says the square of an odd number. So 2n plus 1 squared, and what that means is 2n plus 1 times 2n plus 1. And if we expanded that, we would get 4n squared plus 2n plus 2n plus 1. And that gives us 4n squared plus 4n plus 1. Now what I'm going to be looking at is looking at what I'm aiming for. I'm aiming to show that something is one more than a multiple of 4. So if we look at this coefficient of n squared here and the coefficient of n, they're both 4. So we can take a factor of 4 out of those to give us 4 lots of n squared plus n plus 1. And now what that shows is that the square of an odd number, that's what we've just done, is always one more than a multiple of 4. We've times by a multiple of 4, and then we've added 1. So this shows here that it's a multiple of 4, as we're multiplying by 4. And this shows here that it's always one more than a multiple of 4, as we're always going to be adding 1 to a number that's been multiplied by 4. So that's our final answer for that question. The second question says, y is inversely proportional to d squared. When d equals 10, y equals 4. Then it says d is directly proportional to x squared. When x equals 2, d equals 24. We're asked to find the formula for y in terms of x and give your answer in its simplest form. So the first thing I'm actually going to do is I'm going to sort of create colour codes for each part of the question. And this part of the question I'm going to do in blue. And this part of the question I'm going to do in red. So looking at the blue part, we've got y is inversely proportional to d squared. So we can say y is inversely proportional to 1 over d squared, okay? Y proportional to 1 over d squared, and that makes it inversely proportional. So we can set up an equation saying y is equal to some multiple that I'm just going to call k divided by d squared. And now what I'm going to do is I'm going to substitute these two values in here so that I'm able to work out my k squared for the blue part of my question. So when y equals 4, 4 must equal k over, and then d is 10, so it's got to be 10 squared. So that's 4 equals k over 100. So timesing both sides by 100, k must equal 400. So now what we can do, using this information, is put that back into our original formula here. So we can say y is equal to 400 divided by d squared. And we can't do anything else with that for the minute. So now we're going to have a look at our red formula. So it says d is proportional to x squared. So we can write that as d equals some multiple, which again I'm going to call k, multiplied by x squared. And we've got two values here that we're going to substitute in to find our value for our red equation, our k value in our red equation. So when d equals 24, that's going to be 24 equals k times, and our x is 2, so that's going to be 2 squared. So that's going to be 24 equals k times 4, so dividing by 4 both sides, we get k equals 6. So again, we're going to go and put that back into our original equation here. So that's going to give us d equals k is now 6, so it's going to be 6x squared. Now what we want is a formula for y in terms of x. So we want to eliminate our d's. Now when it says a formula for y in terms of x, we want y equals some function of x, as we want y in terms of x. So if we look at this formula here, we can see that we've got y equals some equation in terms of d. So y is in terms of d here. But if we look here, we've actually got d equals something in terms of x. So I'm going to substitute the d value into this y equation, and then we will have y in terms of x. So we're going to still have y equals 400, and then we're going to be dividing by d squared. Now d is 6x squared, so 6x squared is the replacement for d, and we're still going to be squaring that. When we do that, we still have our 400 on the top, and then we're going to be divided by 6 squared, which is 36, and x squared squared is x to the 4, because if we have a look, if there was no 6 there, that would be x squared squared. Remember, when we've got power to a power, we multiply the power to give us x to the 4. That's a little side work there. And now it wants it in its simplest form, so what we can say now is y equals, and dividing both sides by 4, we get 100 divided by 9x to the 4, and that is our formula for y in terms of x. The next question says simplify fully 3x squared minus 8x minus 3 divided by 2x squared minus 6x. So whenever we're asked to simplify an algebraic fraction, we will always factorise first. So we're going to be factorising the top, and we're going to be factorising the bottom. So first of all, factorising the top, we've got 3x squared minus 8x minus 3. Now there's many ways to factorise, but the way I do it is, say, multiplying the coefficient of x squared by the constant, that gives us negative 9. So our two numbers that are going to sit in our bracket have to times to give us negative 9, and they have to add to give us the coefficient of x, which is negative 8. If you're stuck on having a go at factorising expressions when we've got the coefficient of x squared greater than 1, then I have done a video on those. I will link it in the description, so you can go and check that out and come back here and have a go at the question. But carrying on, we now need to list our factors of negative 9. So that's 1 and negative 9. They times to give us negative 9, and they add to give us negative 8. So those are the pairs that we're going to have. So factorising, we're going to have 3x in our bracket here, and then the plus 1 from here. And the second bracket, we're going to have 3x and then the minus 9 from here. And now what we're going to do is have a look at, do any of these brackets cancel? Well, 3x plus 1, we can't cancel that down. But 3x minus 9, well, we've got 3x and minus 9 both go into 3. So we can say 3x divided by 3 is x, minus 9 divided by 3 is minus 3. And now that's our factorised form. So that's part of our answer. Now having a look at the bottom, we've got 2x squared minus 6x. I'm able to take a factor of 2 and x out to give me x minus 3. Now we'll go and put those back on a fraction. We're going to have 3x plus 1 and x minus 3 on the top. And we're going to be dividing that by 2x times x minus 3. And now having a look what can simplify on top and bottom, we can cancel the x minus 3's just to leave us with 3x plus 1 divided by 2x. And that is our final simplified fraction. Okay, having a look at this question, it says here is the graph of y equals sine x for x, which is between negative 180 and 180 and those extremes. It says on the grid, sketch the graph of y equals sine x minus 2 for negative 180 and 180 and those extremes. So what we've got here is the graph of sine x, and hopefully you're familiar with that graph. Now if we're looking at what we're being asked to sketch, we're being asked to sketch sine of x minus 2. And the minus 2 is outside the bracket. And when we have the number outside the bracket, that is a translation downwards. And in this case, our number is 2, so it's going to be a translation downwards by 2. So let's have a look at some of the points and translate them to downwards. Here we've got a y value of 0, so when we translate that down by negative 2, that's going to come 2 down. Here we've got a y value of negative 1, so that's going to become negative 3. Here we've got a y value of 0, so that's going to become minus 2. Here we've got a y value of 1, so that's going to become negative 1 when translated 2 down. And again here we've got 0, so that's going to become negative 2. And now what we want to do is join our points together. However, the graph says that is our values for x between 180 and negative 180, and those extremes can be equalled. So we mustn't start our graph here, because this is less than negative 180, and 180 is our lower boundary here. So our graph must start on this point, and the same for here, it must end on this point. So starting at this point and joining our graph through, we should get a nice smooth curve going through all the points, and it should look more or less identical to the line drawn in the question, but just translated down by 2. And that is the translated graph of y equals sine x minus 2. The next question says the point P has coordinates 3, 4. The point Q has coordinates AB. The line perpendicular to PQ is given by the equation 3x plus 2y equals 7. And we're being asked to find an expression for B in terms of A. The line perpendicular to PQ is given by this equation. 3x plus 2y equals 7. What we want to get this in is a form that we can recognise. And the form at GCSE that you can recognise is y equals mx plus c, where m's your gradient and c is your y-intercept. So we're going to do a little bit of algebraic manipulation and rearranging to get this equation in the form y equals mx plus c. So the first thing I'm going to do is I'm going to minus 3x from both sides, but I'm going to write the minus 3 first. And then I'm going to divide by 2 to get y on its own to give us negative 3 over 2x plus 7 over 2. And that is the equation for the perpendicular through PQ. Okay, that's the equation of the perpendicular line that passes through PQ. Now, we want to find an expression for B in terms of A. Now, what do we know about perpendicular lines to other lines? So if we've got a perpendicular line going through PQ, and that has a gradient of negative 3 over 2, we can say that the perp line, or the perpendicular line, through PQ has a gradient of minus 3 over 2. So therefore the gradient of PQ is going to equal the negative reciprocal. So that's 2 over 3. We've been given 2 points on the line PQ, and they are the points P and Q. So to work out the gradient of the line PQ, we can do the change in the y's divided by the change in the x's. So that's going to be b minus 4 over a minus 3, and that would give our gradient for PQ. Now hang on a minute, we know the gradient of PQ, that's 2/3, because we worked that out using the perpendicular gradient. So we can set that equation equal to 2/3. Now what we can do is just rearrange and solve an equation for b in terms of a. So if we cross multiply, we're going to be cross multiplying that way and that way. We're going to have 3 lots of b minus 4 is equal to 2 lots of a minus 3. So that's 3b minus 12 is equal to 2a minus 6. And then we want b on its own because we want b in terms of a. So we're going to get b equals some function of a. So if we add 12 to both sides, 3b will equal 2a plus 6. And if we divide by 3, b will equal 2 over 3a. And then 6 divided by 3 is just 2. And that is our equation of b in terms of a. The last question that I'm going to be looking at in this video says n is an integer such that 3n plus 2 is less than or equal to 14 and 6n divided by n squared plus 5 is greater than 1. We're asked to find all the possible values of n. So this was actually the last question on paper 1 of the Edexcel June 2018 maths exam. So what we have to do is kind of treat these inequalities as 2 separate inequalities until we get to the end of the question. So that's what I'm going to do. I'm going to have a look and say we've got 3n plus 2 is less than or equal to 14. And we also have to take into consideration that 6n divided by n squared plus 5 is greater than 1. So looking at this first inequality here, I'm going to minus 2 from both sides to get 3n is less than or equal to 12. And now I can divide by 3 and say n is less than or equal to 4. So that's my first inequality or restriction on n. Looking at the second inequality, I want to find what values that n can take for this second inequality. So the first thing I'm going to do is multiply both sides by n squared plus 5. That's going to give me 6n is less than n squared plus 5 because n squared plus 5 times 1 just gives me n squared plus 5. Now I want to get this in the form ax squared plus bx plus c, like a quadratic, and I want that to be equal to 0, or in this case we want an inequality, don't we? So if we want to get this to one side being 0, I'm going to minus 6n from both sides. So that's going to give me 0 is greater than n squared minus 6n plus 5. I've just put the minus 6n in between. And now what I'm going to do is I'm going to flip this inequality round to give me n squared minus 6n plus 5 is less than 0, just so the 0 is on the right hand side. The equality flips there. Don't forget to change the inequality sign, because if we have a look, the bigger sign is facing the 0, so the bigger side here also has to be facing the 0. Now what I want to do is solve this inequality. So assuming you know how to solve inequalities, the first thing I'm going to do is factorise, and that would give me n minus 1 and n minus 5 is less than 0. Now, what we've got here is a quadratic that's been factorised and it's less than 0. Now we know if we were to sketch this graph, we know that we'll be sketching that on the y-axis and on the x-axis. So this graph would be y equals n squared minus 6n plus 5. And that's how you'd be asked to sketch it, where y equals that. So that means what we're actually looking at is where y is less than 0. Because we can replace n squared minus n plus 5 with y. Let's do a little sketch at the side so we can visualise what's going on. So if I was to draw my x and my y-axis, drawing a little sketch of this, we've got a positive quadratic here because the coefficient of n squared is not negative, it's positive, so we're going to have a positive quadratic. And if we actually have a look where our n values equal 0, this bracket can equal 0 here, n minus 1, or n minus 5 can equal 0. So that means n equals 1 or n equals 5. And actually, this axis here really should be my n-axis as we're dealing with the variable n. So if we were to sketch that, we'd have a positive quadratic looking something like that. And when it's equal to 0, when y is equal to 0, this point here is 1 and this point here is 5. And I know that because I've factorised and just set each bracket to 0 and find my values for n. Now we're going to go back to this point I made earlier, where y is less than 0. So y is less than 0 when we've got -1, -2, -3. It's this part here. So that's where y is less than 0. So where y is less than 0 on the graph is all of this part. So what that means is we've got the part of the graph here where our values here, our critical end values, are connected. So we're going to have a closed solution set. We're going to have one that we can merge together. So our n values are going to be 1 and 5. And we're looking at n's, aren't we? N, yeah? And now we just need to decide what inequality will sit between the n. Now if we have a look, we've got n is less than here, we've got a less than here, a less than here. So we're going to have less thans also here. So now we've got the inequality for this part as well, okay? This is now our inequality that we've worked out there. So now what we need to do is merge this inequality and this inequality together. So what that means is n is less than 4, and it also equals 4 as well. So that's 4, 3, 2, 1, all the way down to -infinity. And here we've got the values between 1 and 5, but not equal to it. So if we want n is less than 4, and we want 1 is less than n, which is less than 5, these values we can merge together. So we know our bottom restriction is going to be 1. So 1 is going to be less than n, which is less than 5. But looking here, it's got to be less than or equal to 4. So that means we're going to have less than or equal to 4 on our upper end there. Now, if we have a look at the wording of the question, we're being asked to find all the possible values of n. Now that to me is just an inequality. So we actually need to explicitly list the values of n that this inequality can take. So it's all the way from 1 to 4, but it can't equal 1 and it can equal 4. So the values that it's going to take are 2, 3 and 4. And that is our final answer for that question. So hopefully now you have a better understanding of how to answer those types of grade 7, 8 and 9 exam questions.